A thin veil of solar light flickers across the blackness. In the center, a faint blue dot glows Earth, tiny, distant, unaware. And somewhere between that fragile world and the furious heart of the sun, something is moving. A streak of light, tumbling end over end. 3IATLAS. An object from beyond our solar system. An interstellar visitor now diving dangerously close to the sun. NASA's solar observatories have seen comets before. But this one is different. It isn't following the familiar dance of ice and rock that most comets obey. Its path twists, its color shifts, and its speed is accelerating in ways no one predicted. Inside NASA's Solar Dynamics Laboratory, alarms flicker across the screens. Spectrographs show wild spikes. Infrared signatures rise and fall in seconds. Something inside 3IATLAS is changing heating, expanding as if reacting to the sun itself. No one knows what's happening next, but if this object truly came from another star, then its final moments near the sun might hold clues to how entire solar systems are born and how they die. This is the story of 3IATLAS, the interstellar traveler that came too close to our star. The name 3IATLAS sounds technical, almost unremarkable, but behind it lies one of the rarest cosmic events in modern history. The 3I stands for Third Interstellar. It means this is only the third known object ever confirmed to have entered our solar system from another star. The first, in 2017, was Oumuamua, a cigar-shaped mystery that moved unlike anything seen before. The second, in 2019, was Comet Borisov, more traditional, icy, and natural. But 3IATLAS is something new entirely. Discovered by the asteroid terrestrial impact Last Alert System Atlas in 2023. This object first appeared as a faint, slow-moving dot beyond Jupiter's orbit. At first, astronomers assumed it was just another long-period comet, but its speed told a different story, faster than any known comet, cutting across the plane of the solar system at an impossible angle. Spectral analysis confirmed it. 3I/Atlas wasn't born here. It came from somewhere beyond the sun's gravitational reach, a wanderer between the stars. For months, it drifted quietly, observed by telescopes in Hawaii, Chile, and orbiting instruments aboard NASA's Hubble and the European Solar Orbiter. Its composition seemed strange, a hybrid of rock and volatile ice, but laced with elements that didn't fit any pattern found in our system. Then, in early 2025, something changed. Its orbit began to curve inward, toward the sun. Computers predicted a near approach, a solar grazing event. For scientists, this was an unmissable opportunity. NASA's Parker Solar Probe and the Solar and Heliospheric Observatory SOHO were both positioned to watch it dive. It would be the first time humanity could observe, in real time, what happens when an interstellar object meets the violent heat of our own star. But as 3I/Atlas drew closer, things got stranger. Its albedo, the way it reflected sunlight, began to fluctuate wildly. At times, it brightened tenfold. At others, it dimmed into near invisibility. This wasn't just melting ice. It looked almost like reaction. And as the solar wind intensified, 3I/Atlas began releasing a thin, glowing tail that pulsed with light, not steady, but rhythmic, like a heartbeat. In late March 2025, NASA's Parker Solar Probe was entering its 10th near-Sun orbit, closer to the star than any human-made object before it. Its heat shield glowed at 1400 degrees Celsius, its sensors drinking in torrents of radiation. But this time, its mission had a silent partner, a faint, fast traveler cutting toward the same inferno. 3I/Atlas. At first, the two seemed destined to miss each other by millions of kilometers. But as Atlas curved through the inner solar system, its trajectory shifted, drawn tighter, faster, like a stone pulled toward a whirlpool. Parker's instruments, tuned for solar physics, suddenly began detecting spikes in magnetic flux that didn't match the sun's own rhythm. NASA engineers watched the data appear in jagged waves. Every 42 seconds, a pulse. Not random, not solar, something else. SOHO's coronagraphs caught the first visual, a blur of light streaking against the sun's halo. Its color was wrong, not the typical white-blue of vaporized ice, but an emerald green shimmer, the spectral signature of ionized nickel and oxygen. That shouldn't have been possible. The heat was too extreme. Those metals should have boiled away instantly. Yet 3I/Atlas was holding together, glowing brighter the closer it got. And Parker relayed its second data set. Scientists froze. The magnetic field around the object was oscillating, compressing and expanding as if generating its own shield. No known comet or asteroid does that. Even Oumuamua's odd tumbling never produced magnetic interference. At Mission Control in Maryland, monitors displayed overlapping fields, the sun's magnetosphere, and a second, smaller one, rotating within it like a bubble of resistance. 3IATLAS was effectively fighting the sun. 4 days, teams at NASA, ESA, and JAXA worked in shifts, mapping every second of the approach. As the object crossed Mercury's orbit, solar wind buffeted at speeds above 400 kilometers per second. Instead of fragmenting, Atlas appeared to change shape. Radar returns showed its cross-section, stretching from a compact oval into an elongated structure almost 800 meters long. Scientists debated whether it was rotation or outgassing, yet the jets seen bursting from its surface were perpendicular to its spin dot. It was as if 3IATLAS was adjusting itself. By early April, the object's brightness reached magnitude -2, visible even in daylight through filtered telescopes. Social media lit up with images, a green flare rising beside the sun at sunrise. People called it the alien comet. NASA called it an anomaly under study. But inside the Solar Dynamics Observatory, something deeper emerged. Spectral scans showed compounds never cataloged before, complex silicates infused with ammonia crystals, wrapped in carbonaceous dust. Within that mixture lay traces of polycyclic aromatic hydrocarbons, molecules linked to organic chemistry. These same molecules exist in interstellar dust clouds, the seeds of life across the galaxy. If 3IATLAS had carried them through interstellar space, its solar encounter might now be releasing them into the sun's own wind. A cosmic exchange, alien dust, mixing with ours. Parker's next pass came dangerously close, 6.2 million kilometers from the surface of the sun. In that crucible, the probes, cameras, captured faint arcs extending from Atlas's tail, not random jets, but concentric rings of energy. Each ring expanded, then dissipated, forming shock fronts in the plasma. It looked eerily like sound traveling through light. When analyzed, the pulses matched the earlier 42-second magnetic rhythm. Whatever was happening inside the object was now interacting directly with the solar wind, modulating it, almost like communication through pressure waves. NASA officially ruled out artificial origin, but the data spoke otherwise. Some researchers quietly called it the solar whisper. Then came the moment that silenced every control room. On April 17, 2025, at 11:26 UTC, Parker's coronagraph recorded a massive coronal ejection bursting from the sun, a billion tons of plasma hurled into space. It was on a direct collision path with 3IATLAS. The team expected total disintegration. Instead, the object flared brighter than Venus, then vanished from optical view. Every sensor went white. For 22 minutes, there was nothing but static. When the feed returned, 3IATLAS was still there, dimmer, fractured perhaps, but intact. Its path had changed, deflected by several degrees. It had survived a solar explosion that should have erased it. Scientists compared the energy levels. The CME carried over 10 joules. For Atlas to resist that, it must have an internal structure unlike any natural comet, perhaps metallic, perhaps crystalline. Infrared readings showed a core temperature stabilizing around 100 degrees Celsius, the melting point of certain alloys, and yet, analysis of its spectrum suggested a surface of hydrated silicate, not metal. Something was hiding beneath that crust. By April 20th, its trajectory confirmed the inevitable perihelion closest approach, less than 0.2 astronomical units from the sun. For reference, that's inside the orbit of Mercury. At that range, the surface temperature exceeds to 0 degrees Celsius. Even tungsten would melt. Still, telescopes captured it glowing with almost self-luminescent light, pulsing faintly even when backlit by solar glare. As it neared the sun, solar probes lost optical lock. Only NASA's heliospheric imager kept receiving intermittent flashes, coded bursts of brightness, equally spaced. Some called it coincidence. Others whispered of intent, and came silence. The day 3IATLAS reached its closest point. Every major observatory lost track simultaneously. Not because of distance, because the object passed behind the sun. For 36 hours, there was nothing. When it finally re-emerged on the opposite side, astronomers expected a cloud of debris. Instead, they found something impossible. The object had split two fragments, orbiting each other, bound by gravity. The tail was gone. The color had shifted from green to a deep cobalt blue. That blue meant one thing: the presence of ionized oxygen and molecular nitrogen, atmospheric gases, trapped and released. No comet has ever done, across research centers. Theories multiplied. Some proposed it was a collapsed planetary fragment from another system, its core reawakening under solar heat. Others believed it was just coincidence, physics playing tricks with data. But deep within those fragments, spectral echoes hinted at something else, a hollow resonance, like a shell ringing from the inside. By the time the fragments drifted past Venus's orbit, NASA's instruments recorded one last anomaly, a faint, repeating emission near 1,420 MHz, the same radio frequency used by SETI to search for alien signals. Coincidence? Perhaps, but for scientists staring at their monitors in that silent control room, it felt like the universe had just whispered back. In the days that followed, 3IATLAS became more than a comet. It became a scientific reckoning. NASA's official statement was cautious. 3IATLAS remains under observation. Current models suggest fragmentation consistent with interstellar origin and thermal stress. But behind those diplomatic lines, scientists were shaken. For the first time, we had watched an interstellar body interact with a star and survive. Its resilience wasn't supposed to happen. The solar heat should have stripped it bare, leaving a trail of dust. Instead, Atlas endured one of the harshest environments in the solar system and emerged, changed. That transformation triggered a flurry of research across planetary science and astrochemistry. NASA's Goddard Space Flight Center led the analysis of the returning light spectrum. The data revealed complex, high-temperature reactions inside the fragments, evidence of crystalline silicates forming, breaking, and reforming in seconds. It was as if the object was rebuilding itself as it burned. Even more astonishing was the molecular residue captured by the SOHO spectrometer, chains of carbon, hydrogen, and nitrogen precursors to amino acids. These were the same building blocks detected in interstellar dust clouds and carbonaceous meteorites that once seeded life on Earth. The implication was staggering. It meant that 3IATLAS wasn't just a visitor, it was a messenger, a fragment of another planetary system carrying the chemical fingerprints of life itself. Across the world, observatories from Chile to Japan confirmed similar readings. The European Space Agency's infrared instruments found that one of the twin fragments contained traces of ammonia, ice, and oxygen compounds, something rarely seen beyond Neptune. These volatile ices could only exist if the object had formed in a colder, more distant region than our own solar nursery. Perhaps, billions of years ago, it was born around a red dwarf star or a collapsing nebula, then ejected, cast adrift through interstellar space for millennia. Before being pulled in by the sun's gravity, that idea reframed everything scientists thought they knew about planetary formation. If interstellar debris like 3IATLAS can survive for billions of years between stars carrying organic material and structural complexity, then the raw ingredients for life might be far more common than we ever imagined. As one NASA researcher put it during a live broadcast, it's as if the universe keeps recycling life's chemistry over and over again, from one star to the next. The discovery also reignited debates around the mysterious first visitor, Oumuamua. For years, scientists argued about its shape, speed, and origin. Some claimed it was artificial. Others said it was a hydrogen iceberg, but 3IATLAS gave them something observable. Real data, patterns, chemistry, survival, and an unmistakable transformation under solar stress. If Oumuamua had behaved this way, maybe humanity's first interstellar encounter would have made more sense still. The mystery of that final signal, the faint radio pulse at 1,420 MHz, lingered. It was likely natural, a resonance from charged particles oscillating in the magnetized plasma. But to the human mind, it carried symbolism too heavy to ignore. That frequency, known as the hydrogen line, is the universal marker of communication, the cosmic language every intelligent civilization might understand. And now, it had echoed from a dying interstellar object as it passed by our sun. NASA refused to speculate. But in private conferences, astrophysicists asked a haunting question. Did we just witness the death cry of a world long gone, or the echo of something trying to remember its origin? Either way, the event left an imprint deeper than data. Because for the first time, we didn't just detect an interstellar object. We watched it change, and in that change, its light, its resilience, its chemistry, we glimpsed a truth that transcends science, that even in the most hostile places in the universe, something always endures. Asterisk. When 3IATLAS finally disappeared beyond the reach of our instruments, silence returned to the solar system. No flash, no explosion, just a faint trail of ionized dust curving away from the sun. The last fingerprint of a traveler that had crossed the void between stars. For months, that dust continued to drift outward, illuminated by sunlight before fading into the black. NASA's probes kept watching, hoping for one last reflection, one final whisper of data, but space is patient, and it remembers in its own quiet way. What remains is not the object itself, but what it revealed, that the universe is far more connected than we ever dared to imagine. Tiny worlds can carry the chemistry of life across impossible distances. Star systems can trade their materials like cosmic seeds, scattering fragments that may one day fall upon another world's oceans, mountains, or deserts, just as Earth might once have received its first spark. The same way in that sense. 3.1. Wasn't destroyed. It became part of us, its dust, now blended with the solar wind, will spiral outward for millions of years, a silent archive of another sun, another time, another beginning. And maybe, somewhere far away, another civilization will look up at its own night sky and see a strange comet passing by, a fragment from our solar system, and wonder, as we do now, who sent it in the endless silence of space. Discovery is never loud, it is patient, it is fragile, it is the quiet realization that even across billions of miles, and billions of years, we are not alone in the story of creation.